Right, so let's look at the fifth set from slot 1, CAT 2018, the DILR section. So in this question, you have been told that you are given an n cross n square matrix and you have to fill it with numbers such that no two adjacent cells have the same number. And they have also given the definition of adjacent to make it very clear. That is that they can't, they touch each other horizontally, vertically or diagonally, then it will be adjacent. Right, so basically if there is a number over here, then the number over here will be adjacent, over here will be adjacent, over here and so on. Right, so basically in all directions it will be adjacent. Right, so in all these directions. What else does the question say? It says that a cell in one of the four corners has 3 cells adjacent to it, and a cell in the first or the last row of the column which is not in the corner has 5 cells adjacent. This is fairly simple. If you draw a matrix, then as we will do right now, you will realize what they are talking about. And any other cell has 8 cells adjacent to it. So information that we already know, not of much use. The main thing is of course that we need to ensure that no two adjacent cells have the same numeral. Right, so this is a question, and this is the data that is given, and of course the first question tells us to figure out what is the minimum number of numerals needed to fill up a 3 cross 3 square matrix. So instead of starting with a 3 cross 3, let's take it a step back and let's look at a 1 cross 1. So 1 cross 1, of course, you have only a square and you can put only one number in this. So of course, you are going to have only one number, right? So you can have a minimum of one number. But what about a 2 cross 2? So 2 cross 2 will be this way, right? So I draw this grid, this matrix, and I have these 4 boxes. So now if I put a 1 here, I can't have a 1 over any of these places. So I need to put a 2 over here. And if I put a 2 over here, I can't have 2 in either of these. So I need to put a 3 over here. And of course I need to put a 4 over here, right? So of course the numbers aren't really important. So I can put 1 here, 2 here, 3 here, 4 here, doesn't really matter. The more important concept is that the minimum numbers that are required to fill up this grid is 4 in this case, right? Let's take it one step ahead, which is what the question is asking us to do. So 3 cross 3. So now we have this grid. So let me just draw this. So you have this one, and here, right? So of course we will start with the same way. So 1, 2, right? Again, this can't be 2, this can't be 1, so this has to be a third number. Again, this can't be any one of these 3 numbers, so this has to be a fourth number. And then we need to fill up the other ones. Now of course one way is, because this is a 3 cross 3, the number of missing values are few in number comparatively. So we can easily just plug in values and see which one fits. So for example, I can put a 3 here, I can put a 1 here and so on. It really does not, cause any problem as such. But the moment you go up to 4 cross 4, 5 cross 5 and grids higher than that, you will see that it's very difficult to just plug in the numbers randomly. There has to be some logic to the way in which you actually fill in the numbers. Because if you don't get the logic, rest assured 5 cross 5 that matrix will be very difficult to crack. So what is the logic over here? The logic is very simple. That is, once we have this pattern with us, we simply need to keep repeating this pattern, because if I put a 1 and a 3 and a 2 and a 4 next to this, for example, I am ensuring that the numbers which are coming are equidistant from the numbers which have been used before. So basically the point is, I'm trying not to repeat the numbers again, right, adjacent to this. So I'm trying to use the numbers like this, 1 and 3, so that if I can't put a 4 over here, I can put a 3 and a 1, it really does not make a difference, but then I'll have to think about the number over here. So it's basically important to keep the same pattern. So I just keep imprinting this 1, 2, 3, 4. Again, I can put 1, 2, 3, 4. See, you can see that none of the numbers repeats. I can keep doing this horizontally, and of course I can keep doing it vertically as well. That's exactly how we are going to solve this problem over here. So let me just rub this off. So this is a 2 cross 2. Let me repeat the concept of a 3 cross 3 in the same way. So I have 1, I have 2, I have 3, I have 4. I will put a 1 again over here. And the logic is that I need to put a 2 over here, but since we are only looking at a 3 cross 3, I am not really concerned about this. But I will put a 3 over here because I am repeating the 3 again, right? Similarly, what about here? Again, I'm going to repeat the same block. So I'm going to put 1 over here, 2 over here. And again, I would have put 3 over here and 4 over here, but there is no need because it's a 3 cross 3 grid. So of course, I need to put a 1 again over here. And that's it. We have arrived logically, systematically at an elegant solution, right? So this is the answer. That is, we need 4 numbers. So we need 4 numbers whenever we are having a 3x3 square matrix, right? Very logical, very simple. Again, try and think in terms of logic. Don't try and plug in the numbers randomly. There has to be a method to the madness, right? So now let's go to the second question. Second question says, what is the minimum number of different numerals needed to fill a 5x5 square matrix? So 5x5 square matrix, again very similar to what we have done, but let's just draw the matrix and we will see. So I'll just draw this, make the columns, and of course 1, 2, 3, 4, and of course is the last one, right? So this is a 5x5 grid. What will I do? I again start with the same thing. So I'll put 1, 2, 3, 4, and I know I need to keep repeating this. So 1, 2, 3, 4. Again I'll repeat this. So 1, 2, but again I don't need to put 3, 4. Let me repeat that same block again. So this is 1, 2, 3, 4 again. Again 1, 2, 3, 4. Again 1, 2, 3, 4. Right? And again 1, 2 is not required. 3. So 1, 3, and 1. So as you can see, with the same 4 numbers, we have again filled up this grid, this 5x5 matrix. And none of the adjacent cells as such are repeating, because if I have a 1 here, I have ensured that I put it at equidistant proportions, right? You can see that it's always 2 steps away. 3 is always 2 steps away. 2 is always 2 steps away. That's because I have done it logically without randomly plugging in the numbers. So again, for this question as well, we need only 4 numbers. Fine. Third question, slight variation. So now you are allowed to make one mistake, that is, one pair of adjacent cells can have the same numeral. So again 5x5 matrix, but now one pair can have the same. So for example, I can put a 2 here instead of a 1 because 2 is adjacent. Will it make a difference to the number of values as such that we are using? Not really, right? Because we are only allowed one error. The remaining ones will remain as it is. Or for that matter, for example, if I replace this 4 over here with a 3, the remaining 4s will remain as it is. So this and this will be remaining as it is. So I will anyway need 4 numbers to complete the grid. And that is the reason why for this as well, the answer is 4. Right? So you will need 4 at least to fill up a 5x5 matrix. Finally, the last one. Suppose that all the cells adjacent to a particular cell must have different numerals. So what is the minimum number of different numerals you need to fill up a 5x5 matrix? So the same thing, but slight variation is that, so for example, this 4 has a 1 over here, 1 over here, 1 over here, and 1 over here. But now it can have only 1, 1, right? So these values have to change. So think logically, if I'm having a number over here and I need to fill 1, 2, 3, 4, 5, 6, 7, 8. So I need to fill up the 8 places around this one number. So there are a total of 9 numbers. What will I simply do? I will take an extension of whatever I did here and I will say, let this be 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope this makes sense, because now if I take a 5, it will always be, there will never be any number which is repeating around this. And if I repeat this again, so if I repeat this again, for example, you can see that again with 6, none of these will repeat. And again, if I put a 2, 5, 8 over here, again you can see with 4, none of them will repeat. Right? This is the basic logic to it. So we are doing it logically, we are doing it systematically, and hence it will work for sure. So for a 5x5 matrix, again, what will I do? Okay, let me not draw the grid, I'll just simply write it down. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. Right? We are done with 5 rows as such. Let's come to the columns. So 1, 2, 4, 5, 7, 8, 1, 2, 4, 5. As you can see, if I take any number, if I take 3 for example over here, all the numbers around it are numbers from 1 to 9 excluding the mid number in the middle. That's what is going to happen every time because we have done it systematically. So that is the reason why in this particular case, the answer is going to be 9. Right? So again, I hope you are finding all of this useful. If you do, then do like this video and subscribe to the channel. And if you have any queries, feel free to ask in the comments below.